Hi, my name's Drew, and today I'll be covering the physics of how spiders can stick to walls. So, a spider is an arachnid. They have 8 legs, and each of these legs is covered in thousands of tiny little hairs. And each of these little hairs is then covered in another thousands of little tiny hairs. And each of these little tiny hairs is called a setule. Setules are about hundreds of nanometers wide, and they are essentially the key to how spiders can stick to walls. Now, you're probably wondering what makes these things so special. Why are they sticky? The answer is van der Waals force. Now, if you're not familiar with that, van der Waals force is the sum of attraction or repulsion forces between molecules. The reason I didn't write repulsion was because in this case it would be attraction because the spider's trying to stick to the wall, not disconnect from it. Because the setules are so small, they make so many, like thousands upon thousands of these little tiny van der Waals force attractions. And because of that, they're allowed to stick to the walls, even though the van der Waals attraction force isn't very strong. Now, another major factor in all of this is friction. Friction is caused by the setules because they're pretty flexible. So what this does is the flexible hairs, they then adjust to the crevices of the rough wall, because as we learned earlier, nothing is really smooth. So the setules, the small tiny hairs, can adjust to these small little crevices and get more traction or more surface contact, and it allows them to have much more friction, allowing them to stick or stay up. Now, how is all of this important? Well, using all this information, we can get a rough idea of just how strong a spider really is. So, scientists earlier have calculated that a setule can produce roughly 40 nanonewtons of force. And using that information, we could calculate just how strong a spider is altogether. So let's say that a spider has 600,000 setules in contact with the wall at one time. That would mean that a spider could produce roughly 0.025 newtons force. And using that information, we could then calculate that a spider could carry roughly 173 times its own weight. And that's impressive. Like, I wish I could do that. Now, how is any of this information useful? Using this information, we could create new technologies that would allow us to have stickier surfaces. So we could create like new tape or new gloves that could allow us to, per se, help astronauts stick to shuttles when they're out in space. I hope all of this was useful to you. Thank you for listening.